Hey everyone, ever stop to think what exactly are we made of? Not emotions or dreams, I mean physically. The desk, your pen, even your breath, all made of tiny invisible building blocks called atoms. This isn't a modern idea, though. Thousands of years ago, Indian philosopher Kanada and Greek thinker Democritus had already cracked the concept matter is made of indivisible particles. Of course, they didn't have microscopes, so their theories were pure imagination. Fast forward to modern science, experiments confirmed that yes, everything from air to iron is made up of these teeny tiny particles. As Richard Feynman once said, if all scientific knowledge were wiped out, the one statement worth saving would be, everything is made of atoms. Pretty poetic, right? Let's break down Feynman's famous idea. Every single thing you touch or see, the air you breathe, the water you drink, even the stars, is made up of countless atoms, each moving endlessly. These atoms attract each other when they're a bit apart, but as soon as you try to squeeze them closer, they push back like cranky toddlers who hate being crowded. That's why solids are stiff, liquids flow, and gases spread everywhere. It's just different balances of attraction and repulsion. The forces between them are what we call intraatomic forces. Mathematically, we say F of r equals minus du by dr, which means force is the negative slope of potential energy with distance. So, the secret of why ice is hard, water flows, and steam escapes all lies in that invisible atomic tug-of-war. Alright, but how do we know these atoms exist? We can't exactly see them under a school microscope. Enter one of my favorite discoveries, Brownian motion. Back in 1827, botanist Robert Brown looked through a microscope and saw pollen grains dancing randomly in water. No, they weren't doing a microscopic disco. It was water molecules colliding with them. Then there's diffusion. Ever smelled perfume spreading across a room? That's molecules wandering off through the air all on their own. Crystals gave another clue. Their neat, repeating patterns hinted at a perfectly ordered atomic structure. And chemical laws like Avogadro's told us the math behind it all. So, we might not see atoms directly, but their fingerprints are everywhere, from scent to structure. Now let's zoom way in. Imagine a single drop of water, just one tiny drop. It contains around 1.7 times 10 to the power 21 molecules. That's a 17 followed by 20 zeros. Each atom is about 1/10 millionth of a meter in radius. That's 0.0000000001 meters. Even in gases, molecules are only a few nanometers apart. The numbers are insane, but they explain everything. When billions of atoms come together, their collective behavior gives us properties like density, pressure, and volume. In simple terms, the world you see is just atoms doing group projects, some efficiently, and some, well, less so. So, how do these molecular interactions explain solids, liquids, and gases? In solids, atoms are best friends, tightly packed, hardly moving, just vibrating in place. In liquids, they're more relaxed, close, but sliding around each other, like people dancing in a crowd. And in gases, total freedom. The molecules zoom in every direction, colliding and rebounding like 1,000 ping-pong balls in a box. Their average kinetic energy, that's energy of motion, equals 3/2 kT, where K is the Boltzmann constant and T is the temperature. More temperature means more energy, which means more movement, and that's why heating ice turns it into water and then into steam. Let's test this theory with a quick calculation. Say we take air at 1 atmosphere, that's 1.01 into 10 raised to the power 5 pascals and 300 Kelvin. Using the ideal gas law, PV equals nRT, we can find how many molecules there are in a cubic meter. Substituting the values gives us roughly 2.4 into 10 raised to the power 25 molecules per cubic meter. Now, to find the average distance between them, we take the cube root of the volume per molecule, which comes out to around 3.4 into 10 raised to the power minus 9 meters. That's about 3 nanometers. So even in empty air, molecules are far smaller and closer than our brains can imagine. No wonder air pressure packs such a punch. So, what did we learn? Every object, every drop, every breath is built from endlessly moving atoms. Interatomic forces hold the key to everything, whether something's solid, liquid, or gas, how it flows, and how it reacts. Temperature, pressure, diffusion, all are just the language of molecular motion. In short, the entire universe is a grand molecular ballet, invisible yet beautifully choreographed by physics. And that's the magic of the molecular nature of matter. See you in the next class, where we'll dive deeper into how these molecules behave in gases, and trust me, it's going to be a fun ride through motion, collisions, and energy.